By now, Ethernet has become an integral part of production environments with industrial communication networks and has developed into the standard, as it were. Office networks and automation networks now use the same standard. Connectors, wiring technology, and hardware now suddenly all match. The previously strictly separate data networks can finally merge together. Data can be exchanged conveniently beyond network boundaries, which moves office and production closer together. At first glance, this new situation appears to be a great facilitation, since Office IT would now be able to service the automation network directly as well. It's not that simple, however. Merely physically connecting both networks does not lead to a satisfactory result. Due to their different purposes and requirements, the networks might interfere with each other. While in automation technology, availability is rated above everything else, in Office IT, network security is the main issue of concern. In practice, this mutual interference often leads to faults, and in extreme cases, it may cause a failure of a network or individual components in it. What are the specific interferences that can lead to faults? In office networks, large Ethernet packages are usually sent. In automation environments, on the other hand, a great many small packages travel in cyclic intervals. These packages must arrive on time under any circumstances. Otherwise, the response times of individual components may be exceeded, which would cause them to fail. The components used in the office network have not been designed for this type of communication. Required network scans and broadcasts, all standard mechanisms of the office network, may considerably interfere with automation networks. In automation technology, the communication paths as well as the response times of the networks are of fundamental significance. If large data volumes are now sent into the automation network through network scans, for example, this might increase the response times of individual components, which in turn may cause a failure that leads to plant shutdown. In automation networks, network anarchy rules. Machine manufacturers, for example, supply the respective network infrastructure for their machines, and hence the address space along with their delivery. Adjusting the address space is expensive and often also not possible without difficulties. This may cause address duplication, which in turn may lead to failures. Due to the high demands on productivity in automation networks, the topic of security is often solved quite differently. A supposed security hole in the operating system of a computer isn't real unless this very computer can actually be accessed from outside. Unsuspectingly connecting the IT network with the automation network containing legacy systems creates a gap that opens the gate for malware. However, not only network internal factors play a role, external factors also need to be taken into consideration in automation technology. Environmental conditions in production environments are often harsher. Therefore, the requirements placed on temperature range, vibration sensitivity, sensitivity to damp ambient air, and electromagnetic compatibility are often very high. Maintenance-free components, for example, are often requested without a fan. Office IT systems are always serviced by IT specialists. Automation networks, however, are often serviced by plant service technicians without special knowledge of networks. The network is often part of the machine and cannot be altered. Maintenance and servicing is handled very differently in the various networks. In the IT environment, damage repair intervals of several hours or even days are not uncommon. In automation, every minute will cost considerable amounts of money. Therefore, these intervals are reduced to an absolute minimum or must even be prevented altogether. With its portfolio, Siemens holds the correct answers to the most important questions. Over many decades, Siemens has set numerous standards in the world of automation technology and pioneered the way for the digital factory. An essential part of the Siemens industrial automation portfolio is also the planning and design of industrial communication networks. Hence, Siemens has a high level of knowledge regarding the requirements within industrial communication networks, as well as interconnecting them with the IT network. For further information, go to siemens.com/Scalence.